So when you have a 3D printer, pretty much everything looks like you can print it. It's kind of like when you have a hammer and everything looks like it's a nail. In this case, I have a small espresso pot, and I never got a proper tamper for it. So today I'm going to go ahead and model out a tamper and see if I can get it printed out and see if that helps me use this thing a little bit better. So first things first, you've got the little cup inside that holds the espresso grounds, and you basically just want to measure that. So in this case, when I look at it, it's about 43 millimeters, 4.3 centimeters, something like that, about 1.5 inches. So that's the first measurement you get. Depth isn't so important because it's just tamping stuff down. And yeah, let's see if we can go ahead and model this thing out. So at this point, we're going to model the object using a piece of software called DesignSpark Mechanical. It's free to use, and it's pretty powerful in terms of constructive solid geometry. The way it works is similar to something like SolidWorks, minus the parametric design features. So the first step is to create a new design. The first thing we see is a fresh grid. We want to go ahead and save that design to the hard drive immediately. And we'll call this one the Espresso Tamper. So the first thing we want to do is create a circle that's 43 millimeters in diameter, which is the base of the Espresso Tamper. Then we immediately switch into pole mode, which just allows us to set the height of the physical volume that will form the base of this object. The first time we raised the base, it's 5 millimeters, and then I came back and realized it was a bit too short, so I made it 2.5 millimeters taller. You can see that here. So with the base complete, we now switch our attention to drawing the outline of the handle. First, we create the smaller end of the handle, which is a 15 millimeter diameter cylinder. In two-dimensional space, that's just going to be a line right now. Then, since we know that the height of the handle is going to be 62.5 millimeters, which basically gives us a 70 millimeter total height on the base plus the handle, we use a construction line to draw a measurement out from the bottom of the handle to the top of the handle, and then we can create a line that represents the top of the handle, the width of the top of the handle. Then we can create the body of the handle itself, at least the thicker part, and we just kind of eyeball it. So we know that it's 25 millimeters in diameter, and then in terms of height, we go ahead and go for about 50 millimeters. So we want to do this one for each side of the cylinder that's eventually going to be rotated. Now we switch into plan view, which is a view of the plane formed by the X and Y axes. Now we draw two more line segments that are 1 centimeter tall at the base, and these will form the bottom cylinder when rotated. Now we have a fun part where we create two 3-point curves that connect the top line segments with the bottom line segments and give us a nice curve when the whole object is rotated, which we'll see in a minute. At this point, we just double check the curves to make sure that we got them right. The next step is to switch back into pull mode, which changes all the line segments which were connected into a surface, which we can then start to rotate. So this is a good start for a handle, but let's see if we can smooth it out a little bit. To round the edges of the shapes, we simply select the pull tool and the edges of the shapes that we want to make round, and then specify the radius of the round that we want to create on these cylindrical segments. Next, we need to look at rotating the handle so that it's in the correct orientation with respect to the base. The first step is to make the base visible again. And then simply use the Move tool to grab the rotation handles on the object and rotate them 90 degrees until you see that the handle and the base could be connected to one another. The next step is to use the Move tool to translate the handle geometry so that it rests right on top and centered in the base geometry. DesignSpark has some clever features which allow you to move one piece of geometry exactly up to the surface of another piece of geometry. But in order to do so, you do need to make sure that the reference position that is being moved is set to the bottom of the handle. Watch this section again if it didn't quite make sense what I did there. The next step is to connect these two pieces of geometry into a single piece of geometry that DesignSpark can then operate on. Now that it's a single piece of geometry, we can add a round to the bottom of the handle. At this stage, the tamper is essentially complete. We do a little bit more checking of the rounds, making sure that everything's pretty smooth, looks aesthetically pleasing, and is ready for the next stage of the process, which is slicing. We do one more check just to make sure that the radius is the correct 43 millimeters on the base. And then we go ahead and export the file as an STL file with very fine geometry. You want to make sure to use fine geometry so that the slicer has a lot of information that it can use to make reasonably round circles out of line segments. Keep in mind that a 3D printer is driven by stepper motors, which can do only line segments at a time. Really anything that's being printed is only going to be a series of connected line segments that this thing traces out. The software we're using to slice the model is called Ultimaker Cura. It's by the same people who make the Ultimaker 3D printer, and it has profiles for many different types of 3D printing machines, including the one that I'm using, which is the Creality Ender 3. I'm going to print with standard quality, which means 0.2 millimeter layer heights and 20% infill. Once it's done slicing, copy the file over to a removable hard drive, then plug it into your 3D printer, and you should be ready to print. Here we can see a time lapse of the object being printed. This one is sped up by almost 200 times. In real time, it took about an hour and 45 minutes to print the object. But here we see the object reaching completion in 30 seconds. And last but not least, here's a quick video of me using the Tamper at home. It worked as expected, and I'm pretty happy that the printer got it right on the first try. Thanks for watching. I hope this was a useful introduction to 3D modeling and printing.